Okay, so we have in this question 80 grams of iodine oxide. It's reacting with 28 grams of carbon monoxide to give carbon dioxide and iodine. Here's a balanced chemical equation. We want to know how much iodine can be produced theoretically. So one of these is going to be yield limiting. In order for us to find out, we need to find the moles of each. So we're going to use our formula. N of the iodine oxide is going to be the mass on the molar mass, which is 80 grams on, and we've got 127 times 2 plus the 5 oxygens, and we end up with 0.24 moles of the iodine oxide. Now we want to find the moles of the carbon monoxide. So again, mass on molar mass. We have 28 grams of this one. Carbon is 12. Oxygen is 16. That's going to be 1 mole. Now let's go back over to our chemical reaction and have a look at the molar ratios. The molar ratios of this one, so N of the iodine compared to N of the carbon monoxide and N of the iodine. Now the reason why we do that one is because that's what we want to find out. So we're going to put that in there. The reaction is 1 is to 5 is to 1. So if we have 1 mole of iodine oxide, we will need 5 times that, 5 moles of carbon monoxide to make just the 1 mole of iodine. And that's our molar ratio, and that stays the same. So let's take one of these, doesn't matter which one, we'll go with the iodine oxide, 0.24. Looking at the ratios, 1 would make 1, so we're going to have 0.24. Now, the carbon monoxide ratio needs to be 5 times bigger. So if we do 5 times 0.24, we end up with 1.2. So if we have 0.24 moles, we need 1.2 moles, 5 times that, of carbon monoxide to make the same amount of iodine. We don't have that. We have 1 mole. We are short. This means that this is yield limiting. Is going to run out before we make all of the iodine because we need 1.2, we don't have it. Now the question asks us to determine the amount of iodine. We're going to take amount in this instance to be moles, not mass. It doesn't say mass, so we're going to go with moles. So if we look at that ratio, then this is going to be a 1 in here now. We have 1, not 1.2, we have 1. This is what we have. So if we think about what we need, we're going to need 1/5 there and 1/5 there, because the ratio is 1 is to 5 is to 1. So 1/5 times 5 is 1. So ultimately then it means that we're going to, from 1, make 0.2 moles. So the amount of iodine that we can make given the 80 grams of iodine oxide and 28 grams of carbon monoxide is 0.2 moles. Obviously, if the question had asked for the mass of iodine, we would then use the same formula here to bring it back to a mass that could be produced. But this is our yield limiting question as it stands.